Students, next we can learn the concurrency theorems. Already we learned so many concurrent points. Okay. When the medians are meeting in a triangle, we will get the point of concurrency. Then when the angle bisectors are meeting, when the perpendicular bisectors are meeting, when the altitudes are meeting, like this we will get so many concurrent points. Here we are going to learn another one, CVN. Okay, it is not like median or altitude or perpendicular bisector or angle bisector. There is no condition to draw this line AD. Just from one vertex to the opposite side you have to draw a line. It is the name of that line is CVN. Okay, you see a CVN is a line segment that extends from one vertex of a triangle to opposite side. There is no condition. Okay, it may be the median or angle bisector or perpendicular bisector or the altitude. Okay, so or simply without any condition. Anyway, if you draw one line from one vertex to opposite side, it is the CVN. Okay, here AD is a CVN from A. Okay, the CVN is a person mathematician name. Here, see this special CVNs. A median is a CVN that divides the opposite side into two congruent means median will divide into equal lengths. Okay, so the median, it is also one of the line from one vertex to the opposite side, but it will divide the opposite side into two equal parts. That is only given two equal lengths. Okay, then an altitude is also a CVN. Okay, altitude means it is a perpendicular from one vertex to opposite side, so it is also a CVN that is perpendicular to opposite side. An angle bisector is a CVN that bisects the corresponding angle. Okay, next, what is Siva's theorem? Let ABC be a triangle and DEF be the points on the lines BC. Okay, BC, CA and AB respectively. Then the CVNs AD, BE. So BC, there is a side. You are drawing this, marking the D point on BC. So what is the opposite vertex of this line BC? It is A. So AD is a CVN. AC is a line. So the opposite vertex is B. So BE is the next CVN. AB is a line. The opposite vertex is C. So CF is the third CVN. Okay. CVNs AD, BE, CF are concurrent. The three CVNs are meeting. If and only if BD divided by DC into CE divided by EA into AE divided by FB equal to 1. Where the lengths are directed. We are taking in the correct order. Okay, the direction is correct. This works for the reciprocal of each of the ratio. We can take the reciprocal of the ratio, that is also 1. It will satisfy. Okay. See this diagram, it is the diagram for the CVN. AD, it is one Siva's theorem. AD is one CVN, B is second CVN and CF is the third CVN. Third CVN, how the ratio is given, AD divided by BD divided by DC. Okay, BD divided by DC is equal to CE divided by EA is equal to AF divided by FB. Now you see the order, BD divided by DC equal to CE divided by EA equal to AF divided by FB. Okay, when from one place you are starting and going in the same order. Okay, one by one you are taking the length. The ratio for each side, BD divided by DC. This is a straight line. So we are taking the ratio here. Then CE divided by EA. Next, AF divided by FB. Should not change the order. Don't think of CE divided by AE. AE means the direction will differ. Okay, so you will not get 1. It may be minus 1. So EA, that is only the correct one. Understood? That is the Siva's theorem. Next one is Menela's theorem. A necessary and sufficient condition for points P, Q, R on the respective sides BC, CA, AB of a triangle ABC to be collinear is that BP divided by PC into CQ divided by QA into AR divided by RB equal to minus 1, where all segments in the formula are directed segments. Okay, so here if the 3 points PQ are on this PQ are collinear, see PQR, these 3 points are collinear, means on the same line with the respective sides BC. This P is on BC, then Q is on CA, this extended line, or their extension also mentioned, no? The CA is a line, but it is extended. On that line, you will get a point Q, and AB, this AB line, we have the R point. Okay, but these 3 points are on the same line, that means collinear. Then this condition will satisfy. How it is? BP divided by PC, like Siva's theorem, the first ratio, BP divided by PC, then CQ divided by QA, it is different, okay. CQ whole value, CQ divided by QA into AR divided by RB. Why it is coming this? If the Q point is in between, you will get it correctly CQ divided by QA like Siva's theorem. But now here Q is outside, it is in the extended part. So CQ divided by QA, then AR divided by RB. Okay, so we get it is minus 1. Okay, if you change any one order, here it is mentioned, the note we can see later. Now, so this product is minus 1. Okay, this also we can write for when you cross multiply, you will get the same. Numerator BP into CQ into AR equal to minus PC into QA into RB. Okay, then what is the note you see? If BP is replaced by PB or CQ by QC or AR. Okay, BP is replaced by PB or CQ is replaced by QC. That means if you are change the order, direction. Okay, instead of BP in the Menela's theorem, if you write PB, understood? Not like this. Normally we will write the distance in any order, but in these two sums you don't write that way. Okay, BP is given in the theorem. If you change the BP as PB, your value will differ. Okay, like this way for in all the ratio, this all the sides. If any one of the 6 directed line segments BP, PC, CQ, QA, AR, RB, that all are in this ratio, is interchanged. If any one is changed, then the product will be 1. Okay, since the direction will change, so this product will be 1. Are you all clear? So please learn, understand and learn these 2 theorems, Siva's theorem and Menela's theorem. Maybe it can ask for the 2 more question. Okay, write the statement of, like that way they can ask. So with the diagram you have to write the statement. So please learn it correctly, understand and learn. Okay.